Welcome to our exploration of Python's tuples and sets. While lists are fantastic for general-purpose data storage, Python offers specialized data structures for specific needs. Tuples provide immutable sequences, perfect when data shouldn't change. Sets ensure uniqueness, eliminating duplicates automatically. Let's discover when and why to use each. Python provides four fundamental data structures: lists, tuples, sets, and dictionaries. Today we'll focus on tuples and sets, understanding how they differ from lists and when each is the right choice. Here we see three data structures with the same initial data. Notice how lists use square brackets, tuples use parentheses, and sets use curly braces. Sets automatically remove duplicates. See how the duplicate, b, disappears. Each structure has distinct characteristics. Lists are ordered and mutable with duplicates allowed. Tuples are ordered and immutable with duplicates allowed. Sets are unordered and mutable but automatically enforce uniqueness. Let's dive deep into tuples. They're ordered collections that cannot be changed after creation. This immutability makes them perfect for data that should remain constant. Tuples can be created with parentheses or just comma-separated values. For single-element tuples, the comma is crucial. Without it, Python sees just parentheses around a value. Tuple unpacking allows elegant multiple assignment. Let's visualize what immutability means. Once created, tuples cannot be modified. Here's our tuple containing color names. If we try to modify an element, Python prevents this. Python raises a type error, clearly stating that tuples don't support item assignment. This immutability is a feature, not a limitation. It ensures data integrity. However, we can still access elements, slice, iterate, check membership, get length, and concatenate tuples. Concatenation creates a new tuple rather than modifying the original. While tuples have fewer methods than lists due to immutability, they support essential operations for data access and analysis. Tuples support indexing and slicing just like lists. They have two main methods. Count returns the number of occurrences, and index finds the first occurrence. Built-in functions like len, max, min, and sum work perfectly. Concatenation and repetition create new tuples. Now let's explore sets, Python's solution for managing unique collections. Sets automatically eliminate duplicates and provide powerful operations for mathematical set theory. Here we see a list with duplicate values. When converted to a set, duplicates are automatically removed, leaving only unique elements. Notice how the order might change. Sets are unordered collections. Sets can be created in several ways and modified with intuitive methods. Empty sets require the set function. Curly braces alone create dictionaries. Sets can be created from any iterable, automatically removing duplicates. We can add single elements with add, or multiple with update. Remove raises errors for missing elements, while this card doesn't. Pop removes arbitrary elements since sets are unordered. Sets shine when performing mathematical operations like union, intersection, and difference. These operations are both intuitive and powerful. Let's work with two sets to demonstrate mathematical operations. Union combines all elements from both sets, removing duplicates. Elements 3 and 4 appear in both sets but only once in the union. Intersection contains only elements present in both sets. Here, only 3 and 4 exist in both set A and set B. Difference gives elements in the first set but not the second. Elements 1 and 2 are in set A but not in set B. Let's see how these mathematical operations translate to Python code. Python provides both operator symbols and method names for set operations. Union uses pipe or union method. Intersection uses ampersand or intersection method. Difference uses minus or difference method. Symmetric difference uses caret. We can also test subset and superset relationships with comparison operators. Choosing the right data structure is crucial for writing efficient, readable code. Let's explore when each structure is the best choice. Use lists for ordered data that needs modification, like shopping carts or task queues. Use tuples for ordered data that shouldn't change, like coordinates or color values. Use sets for collections where uniqueness matters or fast membership testing is needed. Here's a decision tree to help choose the right structure. First, ask if order matters. If yes, choose between list and tuple based on mutability needs. If order doesn't matter, sets are great for uniqueness. When in doubt, lists are the most flexible option. Let's see these data structures solving real problems in practical scenarios. Tuples are perfect for configuration data that shouldn't change during program execution. Database settings, color constants, and geographic coordinates are excellent tuple use cases. The immutability prevents accidental modification of critical values. Sets excel at data deduplication and analysis. They automatically remove duplicate user IDs from logs, making it easy to count unique users. Set operations find common interests between users or identify security threats by comparing access attempts against allowed IP addresses. Real applications often combine multiple data structures. Here we process survey data using tuples for immutable person records, sets for unique collections, and set comprehensions for efficient data extraction. Each structure serves its purpose in the pipeline. Understanding performance differences helps choose the right structure for your use case. Let's compare the efficiency of common operations. Here's how the structures compare. Lists and tuples have fast indexed access, but sets don't support indexing. Sets shine in membership testing, checking if an element exists is nearly instant. Tuples use less memory than lists and are faster to create. Sets excel at insertions and removals but use more memory for their hash table. This code demonstrates the performance difference in membership testing. For large collections, sets are dramatically faster when checking if elements exist. The difference becomes more pronounced as data size increases. Let's explore common mistakes and best practices when working with tuples and sets. Common pitfalls include forgetting the comma in single-element tuples, using curly braces for empty sets which creates dictionaries instead, modifying collections during iteration, and assuming sets maintain order. Best practices include safe type conversions and using comprehensions for filtering operations. Let's explore some advanced features that make tuples and sets even more powerful. Named tuples provide structured data with named fields, combining tuple immutability with readable attribute access. Frozen sets are immutable sets that can serve as dictionary keys or set elements. Set comprehensions create sets efficiently with conditions. Multiple set operations can be chained for complex data processing. Let's solve a real-world problem using tuples and sets together. This example demonstrates practical use of both data structures. We use sets to find unique students and courses. Perform intersection operations to find students taking multiple subjects. Use tuples for immutable course year pairs. And combine everything to analyze enrollment patterns across multiple years. Let's summarize when and why to use each data structure. Here's a simple decision flowchart. First, ask if the data will change. If yes, then you need order. Use lists. If yes but order doesn't matter, use sets. If the data won't change and you need order, use tuples. If neither order nor mutability matters, consider your specific use case. Key takeaways. Lists are the most versatile for general use. Tuples ensure data integrity when values shouldn't change. Sets excel at uniqueness and fast lookups. Choose based on your specific requirements. And don't hesitate to combine different structures in the same program for optimal solutions. Congratulations! You now understand Python's core data structures. Lists, tuples, and sets each serve specific purposes. Mastering when to use each one will make your code more efficient, readable, and maintainable. Practice with different scenarios. Experiment with combinations. And remember, the right data structure can make complex problems simple. Keep coding and keep learning. Thank you for joining this exploration of tuples and sets. Keep practicing, keep experimenting, and most importantly, keep coding.